All right. Can you guys still see the screen? Somebody has to open their mic and answer. Thank you, guys. Uh, So, anybody has any questions regarding what we discussed last week or other? These are all fine, no? Okay. What about this one? Attempt this. Let's see. In the Boolean expression, AB plus A bar C plus BC plus ABC, which of the following is true? AB and A bar C are redundant primes. BC and AB are redundant primes. ABC is a non-prime. BC is a RPI. ABC is RPI. BC is a non-prime. Still, you guys see my screen? Hello. Hey. Okay. Thank you. You open your mic and then talk. This is for interaction, man. You you guys have become like chatbots. No interaction, only chatting. Okay, Prabhat is saying it's B. BC and ABC are RPIs. Okay, let's see. By the way, you can see my screen in slideshow mode only, no? Oh, thank you. Okay, fine. So this kind of problems are very easy to understand when you have kind of let's understand what are these implicants, prime implicants, redundant prime, non-prime, all those things through some example. Okay. So let's say, for example, we are discussing about implicants, right? Let's say I have a K-map, right? Three variable K-map. Yeah, just a minute. Let me admit. So let's say this is A, PC, and the K-map coding, right? This is follows gray code, right? 1110. I will write like this. Let's say. Now what will you do? So the essence is you need to get a simplified form. Hmm. So what is a simplified form? Can anybody try to attempt? What is a simplified form means what? What is a simplified form is? You do one thing, boss. Okay, so let's, yeah, somebody is saying. Okay, I know that you attended last week, but that's not exactly, but you are, yeah, 90% right. Okay, suppose if you guys don't know the answer, you must write in the message that don't know. You know, or you don't know, or you speak. That's all. Okay, I want to see the chat. I want to see how many active people alive in the group. If you don't know, type don't know. Great Parsardi, no problem. Hmm. Harshil, can you answer that? Don't know. Very nice. Kushbu, Neetu. Okay, Prabhat, you got something. Some answer. Sri Sai Swati. Hello. Okay, no problem. Okay. Yeah. Parsardi, speak. Huh. Yeah, that is a question. You are asking me a question again. But you heard of prime implicants, redundant prime implicants, non-primes, all those things? Parsardi? Okay, you never heard of that? Okay. Okay, okay, okay. No problem. You forgot. Okay, fine. So now let's see one thing. Let's take up this example. What do you mean by simplified form means? Let's say, for example, let's say I will write a plus ab. Okay, some Boolean expression f. If I say f is a simplified form, right? Now you see this, you know, if you see the number of variables of f, okay, there are two variables. If you say number of literals are, okay, two. What are those? A, B, literals, because B is here, A is here, and variables A and B both are there. If somebody says, yeah, you couldn't see, okay, now can anybody see what I'm writing? I wrote something called simplified form, variable, literals, all those things. No, okay, keep it. All right, all right, all right. Let me stop presenting it. Okay, all right. Now I see why you guys cannot see this. Now can you guys see? Great. So, for example, we are talking about, see, there is not a conclusion about it. We are, be with me. When somebody says simplified form, what he's saying is, right, you have two variables in this, you have two literals in this. Suppose if someone else comes and reduces, let's say, variable to 1, literal to 0, variable to 1, literal to 1, something like this. If we can reduce it further, right, then that simplified form is not a simplified form, right? When you say it is a simplified form, nobody would be able to reduce number of variables and number of literals further. Are you guys with me? Yes, yes, yeah. We are trying to understand prime implicants, non-prime, and all those things. Okay. So the question is, what is a simplified form? How to define simplified form? No, not to that. I'm just explaining the concept. Okay. Be with the answer, no problem. We'll come back to that. Okay. First, I'm establishing what is a simplified form. Based on that, we'll discuss about this, all these things, right? Right. So, are you guys with me about simplified form? So, if you say that this is a simplified form, nobody should be able to reduce it further in terms of variable or in terms of literals. Agree? Right. So now going forward, let's say if I say a plus ab is a simplified form. Tell me whether it is right or wrong. If I give this statement 1, I made it. Sorry? Wrong. Why? Why? Hmm. Hmm. Yeah. So accordingly, what she's saying is there are variables too, literals too in this. But if I take a common, it will become 1 plus b. 1 plus b, everybody knows it is 1. This is a into 1. This is a. In this, variables is 1, literals is 1. Means I can able to reduce it. So the statement is wrong. Are you clear? Is everyone clear? Type it in your chat box. Are you guys clear? Yes or no? All right. Right. So let me erase these things. Okay. Now this is something called K-map, right? Let's come back to K-map. Now K-map will give you the simplified form when you follow certain rules. So what are those rules? Are this? Okay. Now if I take pair of two, I'll get this. What is this? This is A complement C, right? Then if I take this pair, this is BC. Then if I take this pair, this will be AB, correct? Now, what is an implicant is anything can be an implicant. Your A, B, C, according to this A bar C, then BC, AB. Okay. Anything literally can be called as an implicant. But that's not important to us for simplified form, right? So the next category is this. Okay, focus on this. Very, very important. If you know this now, then you can just I can say that simplified understanding of this. Then there is something called prime implicant. Then there is non-prime implicants. Prime implicants, non-prime implicants. So what is a prime implicant? If you take, for example, understanding prime implicant is this. Okay, it is an it is an implicant which is not completely present in another implicant. Please read this carefully if you can understand my handwriting. Otherwise, I'll write it again. I'll read it again. Implicant which is not completely present in another implicant. Now, non-prime is opposite to this. Implicant which is completely present in another implicant. Right? So, I'll take some example. Okay, what is this example, right? Example for this is this. We have A bar C. Now you look at this A bar C. It is an implicant, right? Is it completely present in another implicant? No, it is partially present because this, let me take laser pointer. You look at this. This is an A bar C, right? This is not completely present in another implicant, only partially present. So that's fine. So that qualifies to be a implicant, right? There is a pen. So A bar C is an example. Similarly, BC. You look at BC. Is it completely present in another implicant? Oh, see, this BC 50% present in A bar C, 50% present in AB. Is it 100% present in any other implicant? Hmm? Right? So, since it is not 100% present, BC is also a prime implicant. Now, what about AB? Very clear, now. It's like A bar C. This is AB. Now, what is an example of non-prime? I'll come to that point, right? Now, let's say I will take this. Let's say I will take this example. Okay, let me not. This one, which I rounded. Now you look at this. How is it? How is it present there? Okay. I'm spending most time because I want to get the basics into your brains and hearts and lungs or kidneys, wherever it is. So this is AB. In that, I'm considering this portion. If I talk about this guy, what is this guy? It is A. Okay, this is A. That particular one represents A, B, C complement. Now, suppose if somebody asks, what about A, B, C complement? Since A, B, C complement completely present in AB, are you getting it? Since A, B, C complement is completely present in AB, it will come under the category of non-prime implicant. Are you guys with me? Can you able to find the difference between BC and ABC complement? Okay, let me know through your chat box whether you are clear, because there are so many questions on prime and non-prime and little tricky. If you understand the basics, no trick. It's very simple. You guys understood? Say yes or no between non-prime and prime. Through your chat box. Yes or no. Only Prabhat has replied. Remaining people. Okay, who is that? Neetu, what's your doubt, Neetu? Please tell. Which one? I explained many things there. Which one you are doubtful at? Non-prime, prime implicant. Okay, fine. Okay, Parsardi, what's your doubt? What's your question? You raise your hand. Parsardi? Okay, you raise your hand. You can lower your hand actually. Okay, great. So let me see. You look at the definition is very simple, right? Anything is an implicant, right? A, B, A bar C. Neetu, are you with me? Implicant. Anything is an implicant. A, B, A bar C, B, C, A, B. You need to respond to me, okay? When I'm explaining to you specifically, right? Now, in this, what is called as prime implicant is this an implicant which is not completely present in another implicant. For example, you take A bar C, right? If you take A bar C, this is not completely present in another implicant, right? So it is qualifies to be a prime, right? Non-prime, if it is completely present, just opposite to prime. For example, if you take ABC complement, ABC complement is completely present in AB. You see this? ABC complement is completely present in AB. So this is a non-prime. Are you clear? Nitu, are you clear? Okay. Thank you. Now, the next category is this. This, what is this? Okay. Which color I can take? Ah, perfect. In the prime, you have something called essential prime. Implicant. This is non-essential prime implicant. Don't get confused with the non-prime and non-essential. These two are different things, okay? This is non-essential. Essential, non-essential. There is one more name or redundant prime. Most of the time we will be using this terminology, redundant prime, right? So what is a essential prime? It is a prime implicant, first of all, no doubt about it, and has at least a single one, at least a single one not present in any other prime implicant, right? Now, if you look at again laser pointer, if you look at this one, A bar C is a prime implicant. First of all, it is a prime implicant. It should be a prime implicant. And does it have at least a single one which is present only, at least a single one which is not present in any other prime implicant? If you look at this one, it is present in A bar C and it is present in BC also, both. But if you look at this one, it is present only in A bar C. It is not present in anything else. So, the A bar C qualifies to be, sorry. So, the example is A bar, oh, what is this? A bar C qualifies to be a essential prime. Now tell me whether BC is essential prime or redundant prime. Obviously, the definition of redundant is which does not have at least a single one not present in another prime, or which is not essential prime will be a redundant prime. Can you tell me, according to the definition, BC is essential prime? Yeah, great. That's the right answer. Why? Because it doesn't have at least a single one. Yeah, it doesn't have at least a single one which is present in BC. Right? This one is present in BC and AB. This one is present in BC and A bar C. Okay. So there is not at least a single one which is present. Right? So I can say that, okay, the example is, this is BC. BC is redundant prime. Are you getting it? Now what about AB? What about AB? Exactly, correct. AB is an essential prime implicant because if you look at this pair, right? Now, if you look at this pair, right, it has at least a single one which is present to in only AB, not present in anywhere else, right? That's the definition. Simple. So, AB, right? That's how you need to categorize. I don't think that everybody will get it at a moment. So, what I will do generally is I will have a lot of problems. I think this is not in this slide. I'll do one thing. I will give you a K-map, right? This is a K-map. A, B, C. Coding, gray code, right? 0, 0, 0, 1, 1, 1, 1, 0, right? Again, oh, okay, let me share the entire screen here. What is it? Now you guys can see, right? Okay, so this is the question that I wanted to write, and this one, 1, 1, 1, 1, 1, right? So find number of essential, is it? Okay, why? Okay, I will reshare it. Can you guys see the screen? I think it's loading now. For this question, find out essential prime implicants and redundant prime implicants. How many essential prime implicants are there? Okay, you need to find number of EPIs and RPIs. Answer is like this: 0, 6, 3, 3 is 6, 6. E is none. If any other option is there, I will add that option also. Okay, all right. Somebody said 3, 3. Any other answers apart from C? So for K-map, okay, so you look at group of 8 ones, then group of 4 ones and group of 2 ones, right? Pair. So this is one pair. Group of 8 ones is not possible. Group of 4 ones also not possible. Okay, this one more pair. This is 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 one more pair. How many are there? Let's number them. Let's take this color. This is first one, second one, third one, fourth one, fifth one, sixth one, right? So number of prime implicants is 6. That is very clear. But the question is not prime implicants. The question is essential prime and redundant prime. Any guesses or any answers? So according to the definition, essential prime implicants are 0, redundant prime implicants are 6. 0 comma 6 is the right answer. Any confusions? Any doubts? Open your mic and then talk. So 1, 2, 3, 4, 5, 6. None of them has at least a single one. Okay, none of them has at least a single one which is not present. So this is a redundant prime. Clear, no? Any questions here? Nobody has any questions here? Okay, you guys are very clear, right? So now what is F then? If I ask you what is simplified form of F, what will you tell? So here is the where K-map rules. Okay, there is a K-map rule. What it says is, first you consider only EPIs, and check whether all ones are covered. All ones are zeros, whatever it is. Okay, if you are discussing about zeros. If required, use RPI. If required. Now in this case, there is no EPI only. So first criteria is, first of all, you have to cover all ones. You cannot leave any one, right? And what you need to do is, you need to take a minimum number of RPS, right? So let's say, for example, I have this F, right? A, B, C, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0, 1, 1, 1, 1, 1, 1, like this, right? So what I can do is, I have 6 pairs. I can take this pair. I can take this pair. I can take this pair, right? What is this actually? A complement, B complement. Where is it? AB plus BC? No, no, that's A complement B complement. No? This is BC. No issue, no issue. I really appreciate at least you are responding. No? Okay, F is A complement B complement plus BC plus AC complement. Then someone say, oh, okay, why only this one? I will take another combination, right? What they say is this. Why only that? What you can do is this. Mm, I can take this pair. I can take this pair. I can take this pair also, right? So I can write F. Why? In what way the answer is same? Yeah. When you say answer is same, that's true, but there is something like this. Okay, you need to be little more clear on what we are saying. So yes, if you look at F, let's say this F and this F, I can write one more way also, right? I can take some other crazy form, right? Whether this F or this F, they are logically same. They're really logically same. When I say logically same means you put A equal to 0, B equal to 0, C equal to 0. This also gives the same answer. This also gives the same answer. Algebraically, they may be different. You understood? Yeah. Yeah. Whatsoever. Okay. But these two will logically give the same answer. You try plotting the truth table A, B, C, and then find out F, compute F. Okay. Let's say if I call this as F1, this as F2, your F1 will be equal to F2. No doubt about it. No questions asked. Okay. But algebraically, if you look at it, that may look different. Like because A complement B complement is in F1, B complement C complement is in F2. Okay. Algebraically, it may look different, but otherwise, logically, it is going to be same. So this is a very, very rare and typical problem. A very rare and typical problem where you only have RPS. So that time algebraic way of writing F can be different, but logically they will be same. So in that cases, you need to find all possible, solutions and then figure out the answer. I think there was one question in 2018 or 19. I don't remember because I thought we'll discuss this later, but anyway, the topic has come. So in that, everything, keep tuned to our channel where we can keep discussing about that problems later on also. Okay. So the question is very simple. All RPS they give, and then you need in the answers A, B, C, D, different expressions of F is given. You need to find out which expression is right. Okay. There you must know all the forms, possible forms for F. Are we clear so far? Very good. Now this is like semi-final, right? Like FIFA World Cup semi-final. Now let's see the final. So to understand exactly whether you got it or not, this will tell. This will tell whether you got concept of implicants correctly or not. Hmm? Gray code. Let's say this is pair 1, this is pair 2, this is pair 3, this is pair 4. Okay. So the question is, okay, you need to know whether it is RPI, EPI, right? So we have four options. Okay. You have to map. One is essential prime implicant. This is nothing but EPI. Non-prime, then redundant prime, Okay, these three are there. Now let me know what is P1, whether it is EPI or RPI or non-prime. What is P2? What is P3? What is P4? Hmm. Hmm. Okay, if you take P1 is EPI, P2 is RPI. Hmm. P1, P2 both are EPI? Okay, fine. What about P3, P4? Very good. Okay, option A I got. Okay, P1, P2, P3, P4. All are APIs. Option B. Any other answers? All are RPIs. Option C. P1, P2 EPI, P3, P4 RPI. Option D, none. I can also put one more option. P1, P2 non-prime, P3, P4 essential prime. I told you, no, if somebody answers this correctly, they understood the concept of prime implications. And with this example, definitely you will understand the concept. There is no doubt about it. Should I explain? Type in your chat box yes or no. Are you trying? Option E. Prabhat said option E. Okay. Option B. Okay. No problem. Someone said option A. Someone said option B. Someone said option E. Okay. Enough time is given. Let's dive into this problem, right? So forget about first of all what they gave. First of all, you need to map it. Then you need to compare. F A B C 01 right? Now, first thing is this is 8 squares are there, no? Right? So group of 8 ones possible, group of 8 ones quad, right? Not possible. Sorry, group of 8 ones is octet. How does it matter? So you cannot pair 8. I mean group 8. Group of 4 ones possible. This is quad. This is right. Then anything else? No. Then group of 2 ones possible. That's a final option left. This one and this one, right? These are the three things that are possible, right? Okay, let's number them. Okay, no need to number them. Just look at it. Now you look at this pair, right? It has at least a single one which is not present in anything else. So that is P3, right? So P3 is definitely an EPI. Then this is P4, right? According to the problem. This is P3, according to our understanding. P4 is also an API. Now you look at P1. Where is P1 present? P1, right? So this is like this. 1, 1, 1, 1. Here is a P1. Now P1 is completely present in this bigger prime implicant. Yes or no? So what is this called as? If something is completely present in something else, that is called as what? Non-prime. So P1 is not a prime at all. This is a non-prime. Similarly, P2 is also a non-prime implicant. Not even a prime implicant. Yes or no? If something is completely present in some other implicant, if an implicant is completely present in some other implicant, that will become a non-prime. Accordingly, what is the right answer? Option E. P3, P4 are APIs, P1 and P2 are non-prime implicants. Okay, guys, now focus and tell me whether you have understood the concepts of prime implicants clearly. Yes or no, I want to see in the chat box, all of you. Okay, Prabhat is okay, fine. Remaining people, Ramesh said yes, okay, great. Patsarathi, Kushpu, Soumya, yes, great. Then, who else? That's all. Okay, Neetu, you understood? Okay, great. Thanks. Now, that's all the concept of uh, prime and non. Okay, let's come back to consensus theorem. What is consensus theorem says? You guys know by now, right? F is A P1, A bar P2 plus P1 P2. Then it can be simplified to A P1 plus A bar P2, right? Now let's take one example. AB plus A bar C plus BC according to this can be written as AB plus A bar C. Hmm? Now let's try to have a K map of this guy, right? So F is this, right? Correct? I'll just simply write this because I know this K map. How does it look like? This is A, B, C, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0, right? Hmm? A, B, C. So A, B. A should be 1, B should be 1. Right. Why to confuse you guys? See, this is very simple. This is A, B. What is missing? C is missing, right? So I can write 1. This is can be written as C plus C complement. This is A, B, C plus A, B, C complement. Coding is 1, 1, 1, 1, 1, 0. Where is 1, 1, 1? Here. Where is 1, 1, 0? Here. That's it. Simple. Then A bar C. Where is B is missing, right? Right. This is the order. A, B, C, right? So A bar 1 can be written as B complement B into C, A complement B complement C plus A complement BC. Means this is 0, 0, 1, then 0, 1, 1. Where is 0, 0, 1? 0, 0, 1 is here, 0, 1, 1 is here. Next, what is ABC, right? Now, BC. BC can be written as 1 into. This is A complement plus A into BC. This is A complement BC plus ABC. This is 1, 1, 1. This is 0, 1. Where is 0, 1, 1? 0, 1, 1 is already written. 1, 1, 1 is also already written. Correct? That's why it will become redundant. Already there. right? Suppose you don't know all this in drama. Somebody gave you this K map. When I say that, you don't know all this. You don't know any of this. Somebody gave you the K map. You don't know consensus also. Forget about that. You are a Gajini for some time now. Maybe for 20 minutes or 10 minutes. And don't forget all those implicants and all. Boss, come on. Don't take it seriously. I'm just kidding. Okay. So, if you don't know anything, what will you do? First thing is, you know this pairing, right? You can do this pair, you can do this pair, you can do this pair, right? What is this actually? This is A complement C. What is this actually? A, B. What is this actually? B, C. So what is the idea of K-map? You need to cover all ones, right? You need to cover all ones, right? Now if I draw the K-map again, 1, 1, 1, 1. If I consider all essential primes. That is important. First, essential primes. I know A bar C is EPI, right? AB is EPI, correct? BC is RPI. We have seen 100 times, right? So first consider EPI. Okay, this one is considered. So this is A complement C. Then other one is this EPI. If I consider AB, I have covered all the ones, no? Do I need to consider this point? Yes or no? You don't need to consider that, right? So the answer is F is just write these two implicants A complement C plus C. That's it. Whether you do it by using K-map rules or whether you do it by using consensus theorem, it's the same story, but expressed in different ways. So the idea is you need to reduce number of variables and literals as small as possible and still covering all the ones that are present in the K-map or zeros in other ways. Now we are talking about sum of products form. So I consider all ones. If I talk about product of sum, it's the same story. We consider zeros. The story is a little different. That's all. Are you guys clear with this? Now you understand why BC is called as the RPI? Hmm? Yes. Okay, then let's go back to this. Min terms. Okay, we have seen this, right? I think what is the time now? Okay, I think I want to solve one problem at least before we leave. You solve this problem. I like this problem actually. 4 3 base x is equal to y 3 base. This is how I teach. I keep moving from there to here, here to there so that you just understand the concept. You don't just simply by heart something. You could be able to wake up in your sleep and also able to do this. This is so simple. There is no, what do you say that? You don't need to remember something crazily and then do this. Anybody can do this. X and Y are unknown. The number of possible solutions of X and Y are dash. By the way, am I making your digital topics easy or difficult? Can you guys type it in your chat box? If it is simple, you write simple, otherwise complex. You are allowed to give harsh feedback also. Very good, man. Thank you. So best is convert into decimal. Convert this into decimal equivalents. Then compare, right? So this is radix, right? So if I write in decimal 3 into x power 0, 4 into x power 1. This is 3 into 8 power 0, y into 8 power 1. And these two are equal, right? So 4x plus 3 is equal to 8y plus 3. So 4x is equal to 8y, right? So x equal to 2y. Now, if you look at this system, y3 base 8, right? So the maximum value of y can be 7, right? But it cannot be 8, right? So if y is equal to 1, x equal to 2. So check whether it is valid or not. 4, 3 base 2. Is it valid or not valid? Yeah. Ah, that's great. So this is not a feasible solution, right? Now I can take y equal to 2. X will become 4. Very good. 4, 3 base 4. Does this exist? Is it valid or no? This is also should be the number should be less than 4, right? Because radix, if radix is 4, the possible numbers in that number system will be 0, 1, 2, 3, 4. 0 to 0, 1, 2, 3. That's all. This is also a round. Hmm? Then if I take y equal to 3, x equal to 6. Is that okay? 4, 3 base 6. Is it possible? Yes, it can be valid, right? Y4, x8, y5, x10, y6, x12, y7, x14. See, x can be anything greater than 4. 100,000, 10,000, anything is fine. But cannot be less than 4. Correct? Now, that's what the point is. But y should be less than 8. So I cannot go beyond y 8, right? So how many solutions? 1, 2, 3, 4, 5. 5 solutions are possible for this. Okay. So the answer is 5. Good. So I'm stopping it now. If you have any questions or any queries, let me know. I'll just wait for 2 more minutes. Anything is okay, fine. I will be here till 8:06. Remaining people, you can leave. Yeah, welcome, Ramesh Kumar. I'm also, placing the YouTube channel link where we have discussed so many things. And this is a way I will teach the sequential circuits also. It's all fun. Digital is always fun. No need to complicate the things. So you can follow the channel. A lot of videos are there. You can just see if it is helpful.